Hello cyberspace, my name is Garrett Mills and welcome to episode 1 in my series on version control. In this series we're going to take a look at version control management and what it is, how to use it, specifically using Git, though there are other options, and we're going to take a look at how to leverage it effectively to manage a code base cleanly and efficiently for one person or 20 people. In this episode we're going to take a broad overview look at what version control is, why it's important, and kind of the basic structure that most version control managers use. So let's get started. So I guess the big question to answer is, what is version control? Version control is a form of something called source code management. And source code management devices or platforms are just tools that help you organize and efficiently maintain your code base for whatever project you're working on. And version control is a means of doing this based on revisions or changes to the code over time. And so what a version control manager does is it tracks changes in your code, usually on a file-by-file basis, and it keeps a record of these. And so as you change the code and you revise it and you update portions of it, you can always go back in time and see what was changed at any given point. That way, whether you're doing a project that involves one person or 20 people, anybody who has a copy of that repository or set of code knows the changes that have been made, and it also helps organize and orchestrate changes between people. So say two people are working on a project, me and my friend, and I update file A, and I add a line of code to it, and I save that file. Well, my friend who may not be working on file A, by running a simple command, can get all the updated changes that I've made with just one or two commands. And so that makes sure that everybody is running on the latest code base, and everybody can maintain a working copy of the code that is being modified and the code that's being maintained. Now we'll get into this a little later, but another important thing that a version control software does, specifically ones like Git that we will be using and exploring in this series, is it decentralizes your code. So the same repository, the same information about the code, the changes and revisions over time, can be copied among 1, 2, 3, 40, 70, 100 computers, and you have the same copy of the code, the same copy of the record of changes over time. That way, if any one is lost, you've got multiple copies of it, and then all the revisions that have been made over time. So say you need to go back to a time 4 days ago and get a file before it was changed. Well, you can do that. Say your hard drive crashes, well, you didn't necessarily lose the entire project because it's all backed up to another machine. And so it's also a really good way of making sure that you don't have any single point of failure in your code storage. So that's a brief overview of what version control is. Now I'd like to look at why it's important. And I touched on this a little bit, but basically version control is important for three main things. One, it tracks changes over time. And especially as you start getting a larger and larger code base, it's important to be able to know what file was changed at what time and why it was changed. So a thing that most version control managers do is it lets you comment on these changes, and so you can document why this change was made, and that way in the future, if it ever comes under scrutiny or if it's important to note for some reason that you made X change, that's documented for the record, and if it needs to be undone, then we can go back in time and see what it looked like before you made that change. And it's just really good for maintaining changes, documenting changes to a code base, and making sure that everyone's on the same page when it comes toward working for the same vision for a code base. Moreover, especially as you get more than one person, it helps orchestrate and coordinate communications between team members. So say there's 5 people working on a project. Well, version control, if you didn't have version control, and say we just had a folder saved on my desktop and a folder saved on my friend's desktop, every time I changed something, I would need to make a copy of the changes I made, give it to my friend. Well, that would work all right, but what if he's also changed something? And suddenly it starts becoming very complex to keep everything synchronized. And while we could centralize it and put it all in just one shared folder, Then we run into the third problem, which we'll touch on in a moment. But what version control managers do is it gives us a clean and simple way of syncing changes and keeping changes up to date among many different members and code users, as well as tracking the revisions between team members. So that means that everybody on the team is up to date and they know they have the latest software version, they have the latest version of the code, and they're working with a central base of code that's kept up to date, and it's also decentralized. So this is the problem that I was just talking about, that we could put everything in one shared folder, but then we run into the issue of, well, there's a single point of failure. And especially when you start working on a project that you're putting in hours and hours and hours of time on, you don't want to put it in a situation where there's just going to be a single point of failure and the entire project is lost. And that's where decentralization is important. So version controlled repositories are decentralized, and that means that all of the code and all of the changes to the code are copied across every machine that has a copy of that code. So if I make a copy of the code base on my computer, my workstation, I get a copy of whatever version of the code I'm currently working on, and I get a copy of all of the changes up to that point saved on my computer. My friend can do the same thing, and my other friend can do the same thing. That means across our 3 computers, there's 3 independent copies of the code and all of the revisions that have ever been done to that code. And through a few simple commands, we can keep that up to date. And that means that if any one of our computers fails, or even if any 2 of our computers fails, we don't lose the code, and we don't lose all of the revision history. But that also means that because just the changes are stored, we don't have to store, independent backups of every different version, because whatever version control manager, in our case Git, is storing the changes from version to version rather than snapshot copies of the files every time something's changed. And so that way, if we ever need to go back to a file that's lost, it's possible to do that without needing to dig through years worth of snapshot backups. Now we're going to take a look at the basic structure of a version control repository. So for the rest of this series, we're going to be focusing on a version control manager called Git. Now that's Git. There are many other version control softwares that you can use besides Git, but Git is kind of the gold standard as far as software development is considered. It is the most popular, it's the most supported, and so that's what we're going to be focusing on in this series. So we're going to take a look at the structure of a version controlled project using Git. And so that all starts with the repository. Now the repository is just the place where the code resides. So if you want to think of it like the folder the code sits in, the repository is the folder that holds all of the code, and it stores the data about the changes to that code. So I've opened up GitHub, which is just a website that lets you store repositories and maintain repositories online. And I'm looking at a repository for a project I've got. This is a meta project. It's a plugin for a web development platform called Laravel. And so this is the repository. This is the folder that holds all of the code and also all of the data about the changes to that code. So this is the centralized starting point for all version control, is the repository. It's where everything is done from. Think of it like the base folder. Now the next important piece of the puzzle when it comes to version control is commits. Now a commit is just a fancy way of saying a group of changes. So when you change a file in this project, so say I was working on this project and I changed a file. So I changed, the README file, okay? And I updated this to instead of saying install, I changed it to say setup. Well, I've just changed something, and in order to document that change so that it gets pushed to the repository, I need to make a commit. And a commit is just a group of changes put together. So when I change this file, I run a command. I say git commit, Git commit, and then I give it a message. That message tells Git what the changes to the files that I've done are. So this is a sample commit page. This is how Git manages commits. So it shows the changed files and it shows additions and deletions. So there are a couple important parts of a commit to note. The first one is the message. So every commit comes with two parts of documentation. It comes with a message and it comes with a description. The message is a brief, couple of words just talking briefly about what the changes in this commit do. And the description, if you choose to provide one, is just a more in-depth, like a paragraph style document of the changes. Now the next part of a commit is the code. Now every commit has a unique ID for the repository, and that's used to identify the set of changes in the repository. So you may have thousands of commits in a mature project, and each one of those commits has its own identifier, and it's independently stored by the repository. Now the next part of a commit is the files added to the commit. So when you change a file, in order to commit it, you have to add it to that commit to save the changes. So when you add a file to that commit, it becomes staged or tracked by the version control manager. Staged and tracked is just a fancy way of saying that it's managed with the version control. So in this commit, you can see I've got one file. I'm tracking one file. That's the README file. And you can have multiple files on a commit. It doesn't have to be just one. It just so happens that in this one commit, there's only one changed file. The next thing it tracks is the additions and deletions by line. So 3 additions, 122 deletions in this commit as a whole. And so since there's only one file, that means that there were 3 additions to this file, 122 deletions. And so if we scroll down, GitHub actually lets us view the deletions in the commit page. So you can see I added these 2 lines, getting started and for information, blah, 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 visit the wiki. And then I deleted everything in red. So I deleted all the setup information and moved it to the wiki basically. And then I added this 3rd line down here. So 3 additions, 122 deletions. So it shows the changes that were made. And then once I made the changes, added the file to the commit and gave the commit a message, it saved the commit in the version control. So now all the version control for this project knows that I've made a change to this file. And so anytime anybody else updates the code on their computer using a git pull command, which we'll talk about another time, anytime anybody updates the code for this project on their computer, they're going to get this commit, this change. And so their files are going to update. They're going to no longer contain this portion in red. They're only going to contain the portion in green from now on. And so now if they wonder perhaps why it is that was changed, well, they can come back and look at this commit and see I updated the README to support the wiki. So now let's go back to the code page. So that's kind of a basic overview. So there's the repository and then there's the commits, which are changes to the repository. And the commits are stored throughout time. So I can go all the way back to the very first commit that was made, added updated namespaces. And so I can see that every change that's ever been made to this repository, I can see all the changed files, all the changes that were made. So you can see we changed app to app root in this particular commit. And then I could go anywhere throughout time, contributor update. I can click that and I can see that I changed my email in this one. And so at any given point in time, I can go back and look at any given set of changes that were made for any reason at any time. Now the next portion of a version control repository is the branches. Now, like a tree, code repositories can branch off. And a branch in a code repository is just a copy of the code that is set aside separate. So say I was making a big change to this repository, and that change was going to require lots of commits, individual commits, because you don't want to put too many changes in one commit. You want to try and keep each commit sort of specific to one change. So say I was making a big change and it was going to require 5-10 commits to implement it. Well, rather than push those one at a time, which might break the code in the meantime before I finish them all, what I can do is make a branch to work on. So I can make a branch, which is effectively a copy of the code that I work on, and while I'm working on that, it's separate from the main code. So any changes that may break the code, well, that may break my branch, are kept separate from the main code. So I can be working on that big change while everyone else is working on the main code, and we're not interrupting each other. We're not breaking each other's code, which is a really good thing to coordinate when you are working on a team project. And so say I finish all those big changes, I push 10 commits to this branch, and I'm ready to push all those changes at once to the main code. Then I can merge that branch into the main code, and all of the changes from all of those commits are merged in at the same time, as well as any changes that my colleagues or that I have made to the main code in that time. So it all sounds a little bit confusing, but it's okay. It'll get clear as we go over this step by step in the coming episodes. Now, one last thing that we just want to look at briefly is releases and tagging. So when you use version control management, specifically Git, you can tag points along the code at any given time and set like sort of a snapshot there. So these are usually done for versions, right? So of this repository, there are a bunch of different versions that are tagged. And at any given point, if I need to run an older version, instead of having a copy of that somewhere, I can just use version control to go back to, say, version 0.1.0. And I can click that, and this is a copy of the code as it existed at version 0.1.0. And this is called a tag. So you can tag your repository at any given time, and that tag exists as a snapshot. So any changes you make after that tag, unless you specifically add them to that tag, will not be applied to it. So say I tag this version 0.1.0, this is stable. This is before we made any changes which may break it. We know this works. And then say I make another change. That's experimental. We don't know if it works. Well, we don't push that to this tag. We just push it to the main code. So say I've got customers that are using the stable version of this. Well, they can continue to use tag 0.1.0, and it'll work because we're not changing it anymore. And so points on our code can be tagged at specific versions. And so that's just sort of another fundamental thing that's important to note, is that tags, branches, and commits are the three major portions of version control, specifically when you're using Git. And in the coming episodes, we're going to take a look at how to do all that, like hands-on. But this episode was more about just being a broad overview of the foundations of version control and Git. Alright guys, thanks for watching the first episode in my series on version control. As always, I will be down in comments below if you've got questions, concerns, if you need help with anything, if you just want to connect with me, you can do it down there. You can also connect with me on Twitter, on Google+, via email, on my blog. Links to do all that stuff are down in the description below. Be sure to like this video or share it if you thought it was useful or if you thought it would help someone. And as always, be sure to get subscribed so that you don't miss any of the other videos in my series on version control or any of my other series such as PHP development. And as always, thanks for watching this video, and I will see you in the next one.